All right, we're back. We're still on page 144. It's actually the last page of the notes. We already solved this problem, but what we're going to do is we're going to check it on the calculator. We're going to try to plot them on GeoGebra, and then we're going to look at the next problem and see what we could potentially do. So let's get started with that. So first, I'm going to check on the calculator and see if I got them right. So how can I best do that? I'm going to start a new problem so I can show you in case you're just jumping in here, I guess, which I don't know, it's a weird choice. First, I like to define cis as its own function, and that's cosine of t, and then plus I, which if you're typing, you can type at I, and it'll become the imaginary I. If you're on the keyboard, just hit the pi key twice, I think. So we get this. So now this has a built-in cis. So now I can use that. So I want to check my answers. So I'm going to raise each of them to the 5th power. 3 cis, I'm just going to say t to the 5th, and then I'll feed it t here and say t is negative pi over 10. And it should give me negative 243i, hopefully. It does. Okay. And then the next one is 3 pi over 10. And then if you get 2 of them right, you usually get them all right, because now you're just adding 4 to the numerator every time. And so this is a pretty good way of checking. I mean, it worked. There's another thing we can do that I'll return to it after we do the next problem in the notes, because it's really related to that. So the other thing I was going to do is I was going to switch over to GeoGebra. So here we go. I'm going to choose GeoGebra Classic down here. So it's geogebra.org and choose Classic. And I'll wait for it to load. I usually hit this button right up here so that this thing shows up, mostly so this is not in the way of the first entry line, which drives me nuts. So I hit that. One thing about GeoGebra is it can deal with complex numbers. So if I just type I, you can see it plotted 0 plus 1i. If I type 4 minus 3i, it plots it where it should go. So that's useful. So what I want to do is I want to try to plot these. I'm going to do a weird thing. I'm going to define a function, f of x. And it's going to be the thing that's generating my angles, right? So it's negative pi over 10, and then plus 2 pi over, plus 2 pi, 2 pi over 5, and then times x, right? I don't want to see this, but this is the thing that's generating the angles, right? And then x is really k, and k is really going to go from 0 to 4. So I'm doing that because I'm going to create a sequence, and I would like it to be as compact as possible. So to do that, here we go, sequence. I'm going to use the one that it's choosing here, but I hate that, so I'm just going to type it on my own. So sequence. What am I doing a sequence of? Well, I'm always doing 3 times parentheses cosine of, now here's the trick. I'm going to do f of k, right? F of k is negative 10, oh wow, negative pi over 10 plus 2 pi over 5 times k. That would be f of k. So f of k, so that's cosine, plus I times sine of f of k. And then I have just so many parentheses here. So I think this should be the one that ends it. I feel like I have an extra. We'll find out. Let's let k be the parameter, and we're going to go from 0 to 4. It looks like it worked. And you can see, so what I like about this is you can see, let me just do, put 0, 0 in here. And then it's kind of labeling everything, and that's kind of going to drive me insane. So go into settings and labeling no new objects. That's usually that's my preference. Don't label anything. It's too annoying. Hide that label. All right, so if I do a segment from, oh, actually I think I have to, you know what I could do? Can I do this? Another sequence of segments. Okay, I want the segment from A to L1 of T. So L1 of T, where T goes from 1 to 5. And so what that's doing, so that's a little weird, right? What that is doing is it's doing L1 of 1, which is the first element of list 1, and then L1 of 2, which is the second element, and then L1 of and so on, like 3, 4, 5. So if I change it and just go 3 here, you can see it does when it does the first element, the second element, the third element, and then it stops. If I do 4, I go to the fourth. If I do 5, I go to the fifth. So I get this, and you can see each of these angles is congruent. They're all 2 pi divided by 5 because they're evenly distributed around a circle of radius 3 in this case. So if I do circle, I want the origin, so A, to be the center, and I want the radius to be 3. And there you go. You can see what's actually happening. This is a fun way to play around with them. I recommend it. I mean, to use I, you just type I. I actually used to think, like on my keyboard, I used to do Option I, and it like gives you this stylized I, which is nice, but harder to work with for I don't know what reason. But anyway, try that out. See what you can do. Sequences, playing around with GeoGebra using sequences is like the key to getting a lot of really cool things to happen. So I'm gonna go back to the notes and take a look. I might like hand draw that. I don't know. I know it's not gonna look good if I do, but don't let that stop you, you know? Here's one of the things we can do. Let me try to make a circle. I don't know how I knew that was supposed to be a circle. Okay, circle. And then I know like roughly where they go, sort of. It's like here, and then 5, I don't know. Let me cheat and I will look at the GeoGebra thing. So there's one that's like here, one that's like almost here, one that's kind of here, and one that's definitely there. So these are our things. So this is actually Z0, and then Z1, Z2, Z3, and Z4. So those are our complex numbers. They're all 2 pi divided by 5 apart. If it was the 17th roots, they'd be 2 pi divided by 17 apart. They're always evenly spaced around a circle. It's kind of amazing. So let's see this next problem. What equation is equivalent to finding the complex solutions of x to the 4th minus 1 equals 0? Solve the equivalent problem. Okay, so what do I even mean here? So x to the 4th minus 1 equals 0. So I could say that's the same as x to the 4th equals 1. So then what I'm really doing, I'm going to say it's 1 plus 0i. So what I want to do is say that x is going to be the 4th roots of 1 plus 0i. So that's what I'm really doing. I'm finding the 4th roots of 1 plus 0i. It's an equivalent problem. So we now know that we could find that by saying that r is 1, theta is 0. Then we go through the process and we'll get like z0 is 1, z1 is I, z2 is -1, and z3 is -i, which we did this problem. That's kind of how I know those answers. In Algebra 2, you would have solved this by doing probably like x squared minus 1, x squared plus 1, and then this is x plus 1, x minus 1. I don't know if they teach you to factor this, or like I always just like pretend it's negative, factor it, and put I in. That's like how I do it. So it's going to be x plus I, x minus I. So we get x is -1, x is 1, x is -i, and x is I. So we get all of those. Now, let's look at the calculator and see what we can do, right? So we know we can find nth roots. Like that's not a problem by hand, and then we can use the calculator to like help us with that. But what if there was something else we could do? I'm gonna insert a new problem just to like clear it out. So if I try to solve x to the 4th minus 1 equals 0, this is only going to give me the real solutions. So I would prefer to get all of them. So one option is menu, option 3, and then if you press up, you get to option C, complex solve. Okay, let's try this. X to the 4th minus 1 equals 0. Solve that for x. It's now giving me all the complex solutions. So this we actually could have used. So when we're finding the 5th roots of -243i, so that's like saying x to the 5th equals negative 243i. And I want to know what x is. So let's see what this does for us. This is, so it's going to look weird potentially. I don't know what it's going to look like. Okay, so it looks nuts. I guess somehow it's finding, I don't know how it's finding the, oh, I do sort of know how it's finding like the sine and cosine of pi over 10, but I don't want to be bothered with that. So this is an effective way of finding the decimal solutions. Nobody wants to handwrite this. But negative 3i is in there, which we knew, right? That's the 3 pi over 2 one. So this is something we can do. So you can always use cSolve, complex solve. The easiest thing really, I think, is to do, like, I don't know, I do menu 3, 1, and then just arrow over and put a C in front of it often when I'm on the handheld. Usually I just type it, to be honest. But anyway, there's a big difference between solve and cSolve. Try to use cSolve on all of them. It can at least numerically give you the values. Think about using GeoGebra. And I'm going to go back to the notes just so you can see that we actually have covered all of them. And now it's just up to you to like find some practice problems, play around with different technology things, make up your own problems. Like a lot of the complex number stuff it's pretty simple to make up your own problems. So do that, share them with your friends, check them online on technology, ask questions. And anyway, I will see you in the next set of notes, which are going to be about something else. So see you there.